Hi IB. We're going to look at 20C and 20D in this video, and both of them have to do with the spread of data, which we either look at as a curve or we also look at it as a box and whisker plot, which is what we'll create in 20D as well. So if we just take a look at these first two graphs here, just take note of where the mean and the median and where the most common values are, the mode. So we talked about the other day how usually in a very symmetrical set of data, the mean and the median are very much right in the center, okay? And if you notice, all of the values are very close to the center on this first example. So our spread might be a little bit limited. We might have a smaller spread than, say, a curve that looks like this, where your mean and median, it still looks very symmetrical. However, you've got values that are spread out a lot further from the middle. So this is a little bit wider spread of data that we're looking at. All right, so other ways that we can analyze are actually by creating a box and whisker plot. So when we're looking at a box and whisker plot, we kind of are breaking it down into quartiles. And we also want to know the entire spread. So we talk about the entire spread as the range. And that's just your max value minus your minimum value. So knowing exactly how far spread out our values actually go, we take the max minus the min. And once we do that, we have an idea of basically a starting and an ending point, and now we can break it up even further. So we can look at the median of the entire set of data, which is our second quartile, also known as the 50th percentile, because 50% of the data is below the median. And if we take the median of the lower half, then we have 25% of the data, also known as your Q1, quartile 1. And if you take the median of the upper half, that's your 75th percentile, which is also known as your third quartile. So that middle, this whole measure of the center, tells us that the middle values are very important. So we tend to look at the interquartile range as the Q3 minus the Q1, because that gives you your middle 50%. And that middle 50% is very close. That's kind of where we want to actually focus our analysis, I guess. You want to know the extremes, you want to know your max and your min, but you're very curious to know what's happening around that middle. Where is the middle? All right, because that gives us where most of our values actually occur. So let's actually try this with a set of data. If you were given 12 scores, we have an even amount of scores. So I know that if I have 12 and I think about n plus 1, and divide that by 2, that tells me where my center score actually is. So if I have 13 divided by 2, I'm actually going to have my center score at about 6.5. So 1, 2, 3, 4, 5, 6. So right here is the center of my data. 1, 2, 3, 4, 5, 6. So I have 6 values below the middle, 6 values after the middle. So my median is going to occur right between 7 and 7. So it will just be 7. If I had an odd amount of data, then I could actually use the middle number as my median, and then I could break the lower half that I did not include as my median and the upper half into my 2 halves for me to find my first quartile and my third quartile. So already now we have our second quartile, and in order to find our first quartile, we're going to take the median of the first half. So here we have 1, 2, 3, 4, 5, 6. So again, right here, average between 5 and 6, so 5.5 will give you your Q1, your first quartile, and then 8, since it's between 8 and 8, will be our third quartile. So what we're actually looking at here is that our 25th percentile is 5.5. So our first 25% of our data falls below 5.5, and then our first 50% of our data falls below 7. So this is known as your Q2 or your 50th percentile. And then your 75th percentile, okay, is at 8. So 75% of your data is below 8. So in order to match these up, our lower quartile is right here. Our upper quartile is right here. All right. And our range, again, our highest value minus our lowest value. So we are going to take 9 minus 4, so we have a range of 5 values. And our interquartile range, again, is our Q3 minus our Q1. So we are going to take 8 minus 5.5. And we will get 2.5. So basically, the middle 50% of our data is only 2.5 values away from each other. So that does tell you that our values are relatively close in that middle 50%. All right, just another example here. The 25th percentile is a score below which are 25% of the scores. So again, as we were looking up at the top, 25th percentile here is at 5.5. So 25% of our scores are below 5.5. All right, here's a second example that you guys can try on your own if you'd like to pause the video here. So 20D actually takes you guys into creating your box and whisker plots based off of your 5-number summary. So our 5-number summary was our minimum, our maximum, which we've already talked about as the spread of our data, and then our lower quartile, or our Q1, and our upper quartile, our Q3, and then our median, which is our Q2. All right, so let's try this with this new set of data. Go ahead and pause and see if you guys can figure out where your Q1, Q2, and Q3 values actually are. So with an odd number of data values, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, if we do our n+1 divided by 2, it would be the 6th value, which is our median. So that gives us 8 as our median. And with an odd set, that 8 kind of comes out, and then we're just looking at the lower half from 7 down to 4, and the upper half from the second 8 up to 10. So it does give us a clear center. So 5 is our Q1, and 9 is our Q3. So when we come down to actually making our box and whisker plot, we can plot our Q2, so at 8, that is the center of our box. At 5 is the lower end of our box, and at 9 is the upper end of our box. So our box is actually just around, as much as we can make that look like a box, there we go, is just around your Q1, Q2, and Q3. The whiskers actually go out to your max, which is up at 10, and our min, which is down at 4. So we can tell if the middle of our values is at 8, we definitely have a skew pulling to the left here. So using box and whisker plots, we can also tell where our data is actually skewed, and we can do a little bit of analysis. So this is a negative skew, since the middle of our scores is up here at 8, and then we have this long pull because 50% of our values are between 4 and 8, whereas we have 50% of our values on the upper end between 8 and 10. Okay, so these are a lot closer together than this lower half is. Just taking a look at a few other examples. Symmetrical would obviously be a little bit more centered. So you'd wind up having your box centered and your whiskers, all right, a little bit more evenly spaced so that your 25% actually looks like a quarter of your graph. If we have a negative skew, again, we're being pulled to the left. Positive skew pulled to the right. So take notice as to what your box and whisker plots look like compared with other charts. So this is a dot plot, and here's a histogram. So you wind up seeing how the box plots represent a skew. Also take note, guys, back in year 9 and 10, you guys learned about your outliers. So whatever your data values are, if they are less than your Q1 minus 1.5 times your IQR, then we consider it an outlier. And if it's greater than, if you have a value that's greater than your Q3 plus your 1.5 times your IQR, then we also consider it an outlier. So for example, here's my box and my whisker graph. All right, so 1.5 times my IQR minus, taken off of Q1. So Q1 is right here. Okay, here's my minimum value. So that means my outlier is going to be out here somewhere. Okay, so 1.5 times that IQR taken off of Q1. Same idea here. If this is my Q3 and I add on 1.5 times my IQR, and here's my max, my outlier would be out here. Okay, so we would wind up taking it off and then readjusting our max or our min. It's important to keep it in for analysis because, of course, that outlier is still considered part of our data set, but technically to find an outlier, it's always 1.5 times your IQR added on to your Q3 or taken off of your Q1. And your last challenge, before you guys come to class next time, try to see if you guys can make up a set of 12 scores that might fit this box plot. So if you know that your lowest value is at 3, my Q1 is at 6, My median is at 8.5. And my max is at 10, but also notice that I've got a lot of values here that on the upper end, because we also have our max at 10 and our Q3. So what in the world is happening here? See if you guys can figure out what's going on and what kind of values might represent a box plot that looks like this. Something else to consider is what percentage of data is less than 8.5. So this is my 8.5 right here. What percentage of data is going to be below that 8.5 value? All right, so go ahead and try this. I'll see you guys when you come to class. Have a good night.